Hi everybody, myself Dr. R. Balamurugan, working as an associate professor in the Department of Electrical and Electronics Engineering, K.S.Rangasamy College of Technology. I'm going to explain about the three-phase inverter in 180-degree mode of operation. Let's we explore the slides. So the outline of my presentation is construction of three-phase inverter and thyristor conduction sequences and 180-degree mode of operation. So first of all, we have to know about the inverter. So basically, the inverter is nothing but it converts the DC to AC. So here I am explaining about the three-phase inverter. So the input will be DC and output will be three-phase AC. I am taking a six-step bridge inverter. So here we will be having minimum six thyristors, and each will be connecting for one cycle 360-degree, and each step interval will be explained in terms of 60-degree interval. And for every 60-degree interval, we will be giving regular interval of gate pulses for the sequences of the switches. You can see the circuit diagram here. We can see the thyristor which is connected as an inverted direction. T1, T3, T5 and T4, T6 and T2 are the thyristors, and D1, D2, D3, D4, D5, D6 are the diodes which is connected anti-parallel to the thyristors, which we call it as a feedback diodes. Here this is a controlled inverter. We are using an inverter by using the gate pulses. We are controlling the output voltage of the inverter. In each leg we'll be having two thyristors. We can see odd number of thyristors in the upper end and even number of thyristors in the lower end. For each leg we will be having two types of thyristors, that is T1 and T4, T3 and T6, T5 and T2. We call it as the positive group of thyristors, and we call the lower as a negative group of thyristors. And here the output voltage we will be obtaining as a line voltage and phase voltage. We will be going to see the output voltage waveforms in the upcoming slides. And here I am giving the input voltage, which is nothing but DC, and which is connected with the capacitor. So this is nothing but a voltage source inverter. So let's we see the working of each devices in this circuit. So the output we considering the load as a star connected load. Here we will be connecting the inverter with a star connected load, and we will be measuring the output voltage waveforms. So thyristor conduction, when we see in each leg there are three number of switches will be there in the upper half and the lower half. Each devices will be conducting for 120-degree, that is T1 and T3 and T5. These three thyristors will be conducting in 120-degree pattern, and in the switches in the each leg, that is T1 and T4, or positive group and negative group in each leg will be conducting in two patterns, 180-degree or 120-degree. So in this presentation we will be going to see about the 180-degree mode of operations. Let's we see the 180 mode of conduction. You can see the thyristor pair T1, T4, T3, T6 and T5, T2 will be turned on in each and every interval of 180-degree. And for every 60-degree interval, a positive of positive of switches in the inverter will be turned on, negative off will be turned off, or negative off will be turned on, positive off will be turned off. Like that, it will be consecutively each and every interval. The switches will be incoming switches will be coming inside by giving the gate pulse, and outgoing switches will be going out by naturally commutating. So let's we see the conduction pattern here. You can see we will be having for a cycle as 1, 2, 3, 4, 5 and 6 for 360-degree, which is from 0 to 360-degree. For each interval, there will be three number of switches will be connecting. That is 5, 6 and 1, that is in positive off and negative off, and both the switches will be connecting in the sequences. You can go through the sequences as 5, 6, 1, 6, 1, 2, 1, 2, 3 and 2, 3, 4 and 3, 4, 5 and 4, 5, 6. Again the cycle will be repeated: 5, 6, 1, 6, 1, 2, 1, 2, 3, 2, 3, 4 and 3, 4, 5 and 4, 5, 6. You can observe here in each sequences of 60 interval, the switches, for example T1, T4, T1, T4 will be conducting for 180-degree interval. How we can observe here? Take the T1 switch here. You see here for every 60-degree interval, I will be changing the firing pulses. You see here T1 is conducting for 60 degree. Then again T1 is conducting for another 60 degree. Again T1 will be conducting for another 60 degree in the third interval. So when we add these three, 60 plus 60 plus 60, totally it gives 180 degree conduction. So after the 180 degree, T1 will be turned off, and again another switches will be coming inside. That is, you can see that even number of switches 4 will be given gate pulse. So likewise, you can see here, you observe the next switch, that is number 2. Here it is turned on the second interval, which is conducted for 60 degree. Next third interval for another 60 degree. Then fourth interval for another 60 degree. So totally when we add these three intervals, we can get 180 degree operations. Likewise, each and every switch in the inverter will be conducting for 180 degree. Let's we see the step for getting the output waveforms. There are, for 180 degree mode of operations, 6 steps are there. In step 1, first T1, T6 and T5 will be conducting, and here in that the 5 will be an outgoing thyristor, and 2 will be an incoming thyristor. We will be giving the firing pulse for 2. And now, and in step 3, T6 will be turned off, and again here you can see T6 will be turned off and T3 will be given firing pulse. Again it will be repeated. T1 will be turned off. For each step interval, you can observe one switch will be conducting for every 60 interval and totally 180 degree interval. Like we can have the equivalent circuit for this inverter. So when T1 is conducting, you can see here 1 is conducting, 6 is conducting, 5 is conducting. I can make the step 1 as an equivalent to these waveforms, and I can observe the voltage waveform which is produced, that is line and phase voltage waveforms which is produced for the conduction of T1, T6 and T5. Likewise in step 2, this one thyristor will be turned off and another thyristor will be turned on. You can see here this 5 will be turned off. You can see the open circuit here, and 2 will be given the gate pulse. So totally here one positive group will be turned on and another 2 will be a negative group. You can see here this in equivalent circuit will be changed like this, and 2 thyristors will be turned on and 1 thyristor will be in positive group. So totally the waveforms will be changed, and we can see the output voltage like this. Likewise, we can see the next waveforms also. These are the calculations how the output voltage is calculated for each and every switch intervals. And you can see the step 3 and step 4. Like you can see the number of switches is turned on 1 and 3 and 2. The equivalent circuit will be like this. For 1 and 2, these two will be there, and my output voltage will be Vs by 3. And here negative switches 2 will be turned on, and here you can see the output voltage is 2 Vs by 3. Likewise, the cycle will be, the step will be gone for the next one. You can see the one outgoing will be there and one incoming will be there, and we can have the output phase voltage and line voltage waveforms. You can see the conduction of thyristors for one cycle, and we can observe the waveforms. This is the magnitude of waveforms which we calculated earlier for each and every steps. You can see these waveforms, the line voltage and phase voltage waveforms. You can see the consecutive waveforms which is produced for each and every intervals. So line voltage can be obtained as VAB is nothing but V N A0 plus VB0, or VAB can be written as VA0 minus VB0. This is nothing but here we will be getting the line voltage with the help of phase voltages. Similarly for other waveforms also, other line voltage also, VBC and VCA also. So the points to remember in this working of three-phase bridge inverter is phase voltage have 6 steps per cycle. Line voltage have one positive pulse and one negative pulse for each 120 degree duration. And the phase and line voltages are out of phase with 120 degree. And we can have the inductance capacitance balance in this line voltage. You can see these voltages are dependent on natural load. Thank you. Thank you for giving an opportunity to explain about the three-phase inverter in 180 degree mode of operation. Thank you.